So I am going to try and make this interactive. Actually, I would like it to be at the end. Everyone's going to have math problems to do. We'll have a little, for real, a little quiz. Try to make this quick. Teach you guys how to do a couple things. Maybe you already know it, and that would be wonderful. But just basically, just going to go through flashing. What's a good detail, what's a bad detail, ways to get out of it. If a bad detail is shown by the architect, or if you're talking with a consultant, things to know about expansion and contraction, and then tributary area and how that applies to figuring out how much, what the dead load is and what the wind loads are. So if you're in a design meeting with a customer and they want to know what the loads are, hopefully after this, you'll be able to do that. So first off, what materials are commonly used for flashing? My experience, I've seen 3. So it can either be galvanized sheet metal, GSM. The pros for that are, it's not in our scope. We don't do sheet metal, so it's provided by others. You can get a nice, tight, lapped finish. So you can just bed a piece of flashing down in the ground and then lap another one over the top, 4 to 6 inches, bed and seal it, leave it alone. Galvanized sheet metal does not expand and contract very much, so it doesn't move. So when you bed it and seal it, the caulking won't shear. The cons, in my opinion, are it's more coordination just for you in design and in the field. So if someone else is providing flashing, sometimes obviously it would need to be installed most of the time before the curtain wall. Something that's really easy for the GC to miss or not fully coordinate. And so sometimes it can hold us up in the field, which is a pain. So I'd sometimes rather control my own destiny and have my guys install the flashing so that at least it's not our fault if we won't. It's one less person to worry about on site. So another material is stainless steel flashing, which we could provide. So the positives are it could be provided by us. You can still get your lapped joints. You can still bed it and seal it because steel also has a low expansion and contraction factor. So it's not going to move just by that much when it gets hot. The cons or negatives are it's not usually painted. I mean, I think you can, but it's pretty rare. So if you just get, number 4 polished stainless or number 4 brushed stainless or number 8 polished stainless, that most likely isn't going to match your curtain wall unless you have some tricked out custom fancy curtain wall. So a lot of times, sometimes the architect will ask for aluminum flashing. The positives are that would be by us and it does match the curtain wall, and that's kind of where the positives stop. Because it's aluminum, it's going to expand and contract a lot more than sheet metal and stainless steel. It's one of those numbers you should probably memorize. It's like 0.0000187 or something like that. So you multiply that by a 100-degree temperature range by the length of your part in inches. And then that'll tell you how long that piece of material will move. So general rule of thumb is every 8 feet of aluminum, it's going to expand and contract 1/8 of an inch. So when that aluminum heats up, if it's bed and sealant, the caulking that you bedded in will shear because the aluminum is going to cause it, it's going to grow and it's going to cause it to tear. So we won't provide a warranty unless there's a ugly, we call it kind of a Band-Aid joint at the splice locations. So this is actually a sketch that I did yesterday for Blake. So if you have a piece of aluminum flashing, instead of lapping over with this piece, like sitting over and having like a hairline joint on the side, we usually leave, a 1/2 inch gap in between each piece of flashing. And then this red line on top of it is we lap the caulk joint over 1/4 of an inch on this side, 1/4 of an inch on that side, some bond breaker tape or something in between there so you don't have 3-side adhesion, and then let the caulk joint accommodate the movement between the flashing. So are there any questions so far? Nope, Candace is loving this. Takes silence as a good thing. still muted. That's
What?
fine. All right. So if you get a project and you look at the architectural drawings and they're showing sheet metal flashing comes up and under the window system and it has an upturned leg on the inside. So I'm gonna start picking on people, nothing personal. There's not, who else is in here? How many people do we have? I got a decent amount. All right, so PK, if you had this on your job, what would you tell the customer? You're muted if you're talking, sorry, bud.
Oh, that's all right. Can you zoom in?
I cannot.
It's kind of hard to see.
Okay. There you go.
What was
Okay.
your
So basically you got a little,
Okay.
little flashing upturn leg.
Okay, so the first thing, the first thing is you're going to need to put some end dams at the end of that to create. Oh, you have it there. A bathtub is what I would call it. So that's the first thing that I would point out.
Okay. Does anyone else have any other things that they'd mention to a customer? Catherine, you got anything?
Yeah, we would say you don't need flashing.
There you go. So yeah, so typically architects and consultants would say like, I want 2 lines of defense and caulking is going to fail and I need something in here so that when the caulking fails, it's covered. One, our system doesn't need it. Like Candace said, our system's designed to weep and drain out. We rely on caulking all the time. If they don't rely on caulking, you know, then they got a problem with the whole building. There's no need to add flashing here for us. When they try to insist on it coming underneath our system, what's going to happen when we anchor our sill runner? Caesar.
Yeah, actually, now you have a blind hole.
Yeah. Is that what you were going to say, Caesar?
Yeah, you just poke a hole into it.
Yeah, so basically the flashing would need to be in first. So then we'd have to show up, put our sill runner there, lay out where the holes for our sill runner go, remove the sill runner, drill a hole through this flashing into the concrete, fill that hole full of concrete, full of caulking rather, put our sill runner back down on top of it, and then run our fastener through the hole into a big gob of sealant and then into the concrete hole that we just drilled. So that's called a blind seal. So what I try to do is I do everything I can to get out of this detail. I think this detail sucks. So I always tell people that I can't guarantee that's not going to leak because I can't see it. It's just a gob of sealant that's there. It's a blind seal. I can't guarantee it, so it might leak. So I just poked a giant hole in the middle of your second line of defense, right? And now it's not warrantable. So I can't provide a warranty and guarantee you that I'm not going to cause this flashing to leak. So what I've done in the past to try to meet people in the middle is, if we can do this with stainless steel flashing or with galvanized sheet metal, is they do want an upturned leg. Our caulk joints are usually 3/4 of an inch between the sill runner. So this flashing could be provided by us, and if it's stainless, it could be provided by someone else if it was in sheet metal. I've been able to talk people into like getting a 1/4 inch upturn leg because I don't want, this concrete's going to have some up and down, it's going to have some tolerance, and the GC doesn't want to have to bush it all down, right? So, because the concrete could be installed a 1/2 inch high, the concrete guy is going to say, I'm fine, I'm within tolerance. If your consultant or your architect wants a 3/4 inch upturn leg, then you have it all pre-made, your concrete's a 1/2 inch high, and then your upturn leg hits the sill runner and it doesn't work, right? So the other thing to consider is, like, instead of coming all the way underneath, so now I'm not penetrating my flashing, right? I'm stopping it over here. I'm also trying to avoid the whole shin stack. So usually if I come in about 2 inches from the face of our system, maybe 3 inches if you're captured, If you come in 2 or 3 inches here and try to have this upturned leg in front of the sill runner, now if the flashing guy's late or we're late or whatever, you can still install your sill runner and you can fish this in after the fact. So it eliminates any possible schedule issues in the field. It makes it easier to, you're just not going to have a conflict with the shim stack. You're still able to tell someone and make them feel good about themselves, even though it's kind of not really doing it. I mean, if the caulking fails, this 1/4 inch upturn leg will just delay it. It's still going to be a problem later, but you know, it's you're still working with your customer and your client and making them feel good about it. You're not taking a huge dump on the consultant. You know what I mean? Like he still has his voice heard when you're in that meeting, in that design room. So in my experience, this has been a pretty good way to a happy middle ground that usually works. Like PK was saying earlier, when you do have like a bathtub and upturn leg, that all sounds good until you get to your jam. And then you smash that up against your substrate, your plaster wall or your GFRC or whatever. And then it's really hard to caulk that because that's, you know, now you have a little pinner, 1/8 inch, 16th inch caulk joint on the side of that. That's not really a warrantable joint either. So that's more ammunition. Go ahead, Caesar.
Question. So you're saying if we tell the customer, hey, if you want me to do that, we won't warranty, but then their consultant will?
No, that's exactly it. Like the consultants don't ever provide a warranty. So depending on how you want to, how contentious you want to be, you know, that's like the last line, but you can say it, right? It's like, look, this thing's going to leak. You're sitting over there telling me it's not going to, but when it leaks, I'm going to be the one they're going to call and I'm going to be the one that's going to have to fix it, right? Not you. So this is what I'm going to warranty. This is what I'm not going to warranty. So if I was providing sheet metal flashing and some other company came along and drilled a giant hole in it, I would say, hey, guess what? You just penetrated my system. You voided the warranty, right? So the flashing guy is not going to warrant us drilling a hole through it, right? He's going to say, hey, I installed this flashing. It was tight it was good when I did put it there. Okay. So if this leaks, if the flashing leaks, then they're going to point fingers at us. So we can write a letter saying, I'll do it if you want me to, but I'm not giving you a warranty for penetrating the flashing. I'll still give you a warranty for the curtain wall. I'll still give you a warranty for the perimeter seal like we normally would, but I can't guarantee that this penetration through the flashing is not going to leak.
Okay, that works.
And they're gonna call me. They're gonna call us, right? Because that's how it always works. So, and then depending on how feisty you want to be, you can tell the consultant that they're not going to call him if it leaks. You know, they're going to call you.
So Brian, I got a question.
Yep.
In the case that it does leak on that last slide, and we haven't warranted, we said we're not going to warrant the flashing, obviously, but we will warrant our system. How do we tell which is the culprit, which is the problem, if it does leak?
I mean, if it leaks, you know, if anytime there's a leak, it's usually us and or SPD that goes out there. There's additional diagnostic testing that needs to happen. Anytime the flashing is involved, in my opinion, that complicates the ability to accurately diagnose the source of the leak. So if the window system is sealed right here and the caulking has a failure and water gets in the building, I can go spray a hose on that failed caulk joint, find the source of the leak pretty quick because there's going to be a hole in the caulking and the water's going to get into the building. So then I can have Valley recaulk and patch that hole and I'm done, right? As soon as, like, you know, you might have the caulking failure 20 feet to the side and water could be running in this trough, you know, right to left for forever. And it'd be really hard for you to, before, you know, because the blind seal might work 5 out of 6 times.
I see what you're saying.
So that the water's just going to build up inside there and go all over the place, you know, like, and then now it just becomes way more involved. It's a lot harder to accurately diagnose the source of the problem. So, you know, it's not great when there's a leak. At the same time, we'd like to, if it is our fault, if it is our subcontractor's fault, we'd like to find it as quickly as we can and fix it as quickly as we can. And if you have someone else involved, another trades there, we're going to show up and say, oh, your flashing's leaking. Not our problem. Call the flashing guy. Flashing guy is going to show up and say, hey, these guys penetrated my flashing. Not my problem. Call him. You know, and it just becomes a whole mess for the customer and the TI and whoever's there, the building maintenance guy. You know, it's just a finger pointing fiasco. So, you know, if there is an issue, nice if you can bring Valley out there with you the first time to go take a look at it. If you can go look at it when it's raining, that way you can see it. If you go the next day when it stops raining, it doesn't, you know, you're not really going to figure anything out. You got to bring a hose and try to recreate the same thing, and it's just a mess. So, you know, here the flashing is pretty much just cosmetic. The benefits, the one thing we do need in all these conditions, no matter what, is we need something to caulk to, right? So concrete has seams in it that'll have joints in it. There's usually some below grade membrane or something that kind of runs up the face of it that we're not going to be compatible with, right? So you always want to cap it with something. So it's not just cosmetic. We do want something to caulk to. So we'd rather caulk to a aluminum surface, a stainless steel surface, or a GSM sheet metal surface. And we don't want to futz around at all with this below grade membrane. So this downturn leg, if it is provided, if we are providing the flashing, we do want to make sure that we're talking about how much of a lap do we need, because I've never seen us do this below grade membrane. So we want to make sure that this is covered. Is 2 inches enough? Is 3 or 4 inches enough? You know, what's the tolerance of this concrete? This concrete could be a ½ inch in, ½ inch, you know, right or left. You know, so all of that needs to be, you always want to try to make sure you're remembering what your tolerance is of whatever substrate you're going into. So the concrete could go up and down.
If that was a curb and it's not, doesn't go down below on the ground, is there a need for that flashing? We used to just caulk the top of the concrete, never flashed before. So now has our stance changed?
No, I'm not saying it has. Yeah, if it's a concrete curb, we can caulk to concrete all the time. So, you know, if it's a curb and it's solid, I mean, I have seen leaks, but that's just something I've also just told people, hey, there might be a, you know, you might have to caulk the seam in your concrete. So, yeah.
So real quick, Ryan, so regardless at that ground floor and this detail, there's most likely is going to be flashing. So that's something we should work out in the beginning, figuring out who's providing that, correct?
Because I tell you right now, we typically don't carry the flag, won't carry that flashing in our estimate typically.
Right, but if it goes unsaid,
correct,
like nobody points it out, like who's doing it.
If it goes unsaid, it's still not us.
Well, we have to make sure that in our drawings, we call it out to avoid any argument. It's not by us.
Right, okay.
Hey, Brian.
Yeah, no, yes, go ahead.
2 questions. I sorry if you already talked about this, but that upturn leg, you did mention that everyone hates that, right? That field hates it. It always gets smashed. It never works.
Yep.
You did talk about that?
Yeah, I just said it's a terrible detail and we should try to get out of it. So
okay,
yeah.
Sorry, I was on the phone. And then the other thing is,
problem.
did you talk about the buildup of all the other materials underneath the flashing?
No, that's a really good point. So, yeah, so well, you kind of alluded to it earlier. There's typically some below grade membrane. There's something going up the face of this wall. Sometimes they turn on top of the curb. It depends if it's like a hot mop membrane, like a spray applied. But then, you know, like it's like a roofing detail. It always looks nice and clean and pretty in a CAD detail in our shop drawings. And the buildup, the more stuff you have there, just takes away from the size of our caulk joint between the window system and whatever the top of the flashing actually ends up being. So all of that is something that's great to mention when you're in the room, because we show this nice, pretty 3/4 inch caulk joint to the top of the concrete. You know, you got however thick this flashing is, plus whatever thickness of membrane, you're going to lose 1/8 of an inch, 3/16, maybe more, depending on what's going on, plus then the tolerance of your concrete. So we have to end up with a minimum of a 1/4 inch caulk joint between the flashing and the sill runner. The smallest warrantable joint we can get from Dow is 1/4 of an inch. So we only got a 1/2 inch of play for all those things to be accounted for.
But just like for people who haven't experienced a lot of that, the best thing to do is see if you can either lower that curb if it's not already poured, or, you know, do a mock-up to see just how much buildup you're actually gonna get. I've had to do that on a job before.
Yeah. So yeah, and just to piggyback on Greg's point for everyone, the curb, if it is a curb, which this kind of looks like it is, you know, you wanted to, the main thing for curbs is this anchor, and you don't want to blow out the edge of the corner of the curb. So if they had like a 6-inch concrete curb under our 6.5-inch system, you know, the center line of this wedge anchor to the back of the curb, if it's less than 3 inches, that might be a problem. So if it's like an 8-inch curb and the concrete curb kind of comes over here, then cool. You know, yeah, we can't, caulking adheres to concrete. You don't have to have this flashing. You know, there might be little chips or cracks in the concrete curb itself that someone might need to seal. But if you have a tiny little curb and you have like a steel plate embed, then, you know, you probably would want some flashing. I had that on Britannia and it leaked like a mother. So we had to go back and do flashing. Every time I've done flashing, like Candace said, it was as a change order quote, but it's been somewhat common. It's pretty rare for sales to carry it. They almost always exclude it. But I have been in design meetings and the customers asked me to pick it up. So we did it on all the industrial buildings, all the Britannia Cove buildings, a couple other ones that I've worked on. So it is something that we just need to work out and be real clear about. Hey, I don't have this, but I need to connect to it. So we need to coordinate and make sure that we're comfortable with whatever detail it is that we're working on.
But yeah, BA, if you do price it out, like I think a lot of people don't realize how much work it is to manage that scope. And sometimes if you sub it out, to manage that sub as well. So just make sure you're carrying a pretty decent number if you are pricing it out after the fact.
Yeah, for sure.
Yeah, kind of along the lines of what Candace is saying is that we had an experience out at Merrill where it was another sub doing the flashing, and the flashing also was vertically, and the way they installed it was making the metal bow, and they didn't completely embed the flashing and caulking. So it made when we did the water test, it leaked. Wasn't us, but it was still a big pain in the ass. So
copy that. So yeah, so I mean, yeah, when I've done water testing and, you know, had to have people tape off the flashing because is that part of the test or not? Or sometimes they want the flashing to be part of it. I've had to lay on my stomach with a flashlight to look through for daylight through the flashing to prove that the leak wasn't the window system, it was a leak in the flashing that wasn't bed properly. So all of those things definitely come up and need to be considered. I think that's it for the flashing. I'm going to get into the fun math calc stuff next. Any other questions or comments before we move on?
Yeah, I had a question.
Go ahead.
The flashing upturn leg, I don't know if I missed it, but I just heard there was a lot of trouble it would cause for the field. So what's the purpose of it again? Is it to prevent, like, slow down the leak or whatever?
Yeah, so the upturn leg, typically a waterproofing consultant will say they want like a backup system or belt and suspenders. So in their opinion, the upturn leg provides a second line of defense or a second protection against water intrusion because the water is going to have to come through the hole in the caulking and then build up enough to come up and over this upturn leg before it gets into the building. So when it's in here, it's got to really build up, you know, a full inch or whatever and fill this whole trough. So what I've been somewhat successful with is saying like, hey, I'll give you a 1/4 inch. I'll give you a little bit of a backup system, but that 1/4 inch upturn leg it's still going to allow for concrete tolerance. It's still going to allow for buildup before it gets in the way of my sill runner. So just by, you know, but I won't give anyone a 3/4 inch upturn leg. I won't run it tight to the sill runner because you have to consider the buildup and the tolerance of the concrete, whether it's a slab or the curb. It's not going to be perfectly level. Did that answer your question, Ryan?
Yeah, thank you.
Hey, BA, I sent you a chat. I'm gonna pause for a few minutes, okay?
All right, sounds good. Next thing is tributary area. So if you are in a meeting and you wanted to, someone asks you what's the loads, how much dead load at this connection, how much wind load at this connection. You need to kind of have just a loose understanding of what tributary area is. So tributary area is a loaded area that contributes to the load on the member or supporting that area. So if this was a MAC clip and this was a vertical mullion, so you got like a 5-foot unit and a 5-foot unit. The load on this MAC clip is, you know, half of this piece of glass over and then half of this unit over. And then, so it's basically half vertically and half horizontally. Any questions? I don't know if I explained that super clear. Does that make sense? So if you had a jam, like you'll very, very rarely, I don't think I've ever seen it. I've never had steel reinforcing in a jam. And the reason for that is because jams only get half the load, because when the wind hits the glass, you know, the intermediate mullion gets half the wind from this unit and half the wind from this unit, but the jam's only getting half the wind load. So those anchors are almost always okay. Those jam mullions don't over deflect because they're only experiencing half the load. Okay. So dead load is just the weight of something. So for us in curtain wall, if it's a dead load connection, you know, and someone says, hey, how much dead load is going on here? Like the structural engineer records basically asking like, how much weight are we asking this structure to support? So it's important to understand how our systems go together. The mat clip on the W75 is considered a gravity load anchor. Okay, so when you have your curtain wall unit, we have the hook lugs and we drop it on top of the monkey bar, and we're relying on gravity. Like that thing's just hanging there. So that's a top loaded unit. All of the dead load, all of the weight of the unit is being hung on the monkey bar. Okay, so when you're looking at a section, 206, hold on. Oh shit, where'd it go? Okay, so this is a pretty normal curtain wall. So first floor, second floor. So the triangle in our shop drawings means dead load. So what that means is that this whole weight of this entire first floor unit, it's all hanging on our gravity load anchor on the mat clip. So if this unit weighs 1,000 pounds, it's all hanging on that embed at the second floor. Circle means a wind load connection. So there's no real weight at the sill runner. All the weight of this entire unit's hanging up here. So then you'll also have wind load, and then do dead load connections also experience wind load? What do you think, Jerry?
Do dead load connections also experience wind load? Yes.
Yeah, good call. You had a 50-50 shot, so you got it.
But
So,
I would think so, because you're still getting movement, right?
well, yeah, I mean, the wind's going to hit the whole building, right? So dead load is basically just, you know, like the vertical weight of something like hanging on the structure. And then the wind load's going to hit the whole thing. So typically our sill runners, so let me just show you this. So if this is a big curtain wall, right? So then this sill runner right here is just a wind load connection, okay? This mat clip at the second floor slab is the mat clip and the embed, that's a dead load, but then the mat clip's also experiencing wind load because the wind's gonna hit the curtain wall. So your connection's all your connections are gonna need to be able to withstand some amount of wind load. But then it's important to know where your system's loading on. So a lot of times we'll get to, I should have had this lined up before. but we'll have like a soffit condition and like here. So here I got like a soffit. So I got a curtain wall. So it's typically dead load here, but then this little short guy, there's no mat clip up top. There's no mat clip. I got my mini mat clips going into my head. So the dead load of this unit and the dead load of this unit, you got a double dead load. So the embed here is supporting 2 stories worth of curtain wall. So it's supporting a lot of weight. Does that make sense? Yeah, you can see 4 people. So I'm going to take that as yes. So, okay. So you just want to make sure you're looking at your curtain wall in its entirety. If you had a wide open curtain wall going to a parapet cap up here with an embed in the roof, and you got dead load in your embed in your roof, dead load on the floor below, everything's kind of normal. Surprisingly, this usually isn't an issue. Concrete slabs and the Hilti embeds, they can all handle that much weight. The dead load's usually not too crazy. But that's how that goes. All right, so, and then sometimes you'll have people ask, is it a point load or is the load spread? So going back to, shoot, hold on a second. So if you had a balcony window, you know, so here I got like just a strip window, and here you got a strip window. So you got a sill runner on a balcony, and then I got a soffit condition with some panels. So it's telling me I got a dead load on my sill runner. So we accommodate that by just notching the vertical mullion. So the actual curtain wall unit just sits tight on top of the chicken head. And so all of the weight of that unit is dead loaded on the chicken head. But sometimes this will be on like a pony wall, and then they'll ask you, is the load, is that spread out or is that a point load? And so for us, all of that load is on the vertical mullion at the chicken head. So we're not really putting any weight at all on the stud framing over here. It's all happening at the vertical mullions. And so that's also, so wherever our connections are is where the load's being experienced. So these panels, if you had like a big giant panel wall and you're screwing panels on 12 or 16 inches on center, then yeah, that wind load's going to be spread, you know, pretty evenly across the entirety of the stud framing supporting that panel wall. So usually panels are the only thing where the load spread somewhat evenly. The curtain wall, almost all of our loads are concentrated. So it's concentrated at the mat clip, it's concentrated in the vertical notch on the chicken head at the sill runner, and it all goes right at that point. So it would be considered more of a point load. Okay, so for that, so if you had to pull some numbers real quick, every engineer you ever meet is going to be super conservative. We try to do the same thing if we're just trying to figure things out. So we just kind of tell everyone curtain wall units weigh 10 pounds a square foot. Glass, actual IGUs make up 95% of a curtain wall unit, and the glass itself weighs 7 pounds. If you have glazing panels, that only weighs 2 pounds. So if you really wanted to figure it out, you'd have to add up the length of your stock length extrusions, weight of each piece of glass, weight of the aluminum, or you could get a big scale in the shop and go put the unit on there. But if you're in a room and you're in a meeting and you just had to do some quick math, just figure 10 pounds a foot, and that's safe, that's conservative, that will cover you. So to figure out the dead load, you need to get your total square footage of the correct tributary area and then multiply it by the appropriate weight. So the dead load of a curtain wall unit, you just figure out your square footage of the area and multiply it by 10 pounds. And that'll give you the dead load. To figure out your wind load, you get the total square footage of the tributary area around that connection. So typically you want to think about where your system's connecting to, or how your system's connecting to the building. So on a W75, that's going to be at the chicken head, right, of your sill runner or your stack joint. And then your mat clip, and then your mini mat clips when you have a strip window or a soffit condition. So here is the math assignment or problems to figure out. So on this project, you have 5-foot mullion spacing. The ground floor units are 15'6" tall. On levels 2 and 3, these units are 14'3" tall. And then you need to figure out your wind load, you have to pull the design pressures from your calc package. So we do RFI number 1, we have AWS give us a calc package, and then they tell us your typical zones plus 21 PSF minus 22.73, and then if it's a corner zone, it's plus 21 minus 28 on this job. Okay, so if I wanted to figure out the dead load of how much weight is this mat clip right here supporting, I need to figure out how much weight that mat clip supporting, right? So that's going to be this row of units, and this mat clip's getting half of this unit and half of this unit. So I would just basically figure out, okay, it's 5 foot wide. The height of this unit is 14'3". So if I got 14'3" times 5 foot, that equals, this is going to be fun. You guys are going to watch me do math over Zoom. 5 times 14'3". So that's 71.25 square feet. So the dead load on this anchor is 712.5 pounds. Does that make sense? So Caesar, if this unit is 15'6" tall and 5 foot wide, how much dead load on this anchor? You got it, Caesar?
Sorry, it will be 17,047.
No, the dead load. So if this unit is 5 feet wide and
Oh, I did the 15 feet.
yeah, so 15'6" times 5 feet equals 77.5 square feet, right?
And
And
it's
so then that
10 pounds.
that times 10 pounds.
775.
So that, yeah, 775. Exactly. So then, but then the jam, you know, would be half of that. So this mat clip's got 775 pounds of dead load, same as this one, this one, this one, this one. But then the mat clip at your jam has half of that. So that's going to be 387.5 square feet. Does that make sense? All right.
Yes.
So then, so when it's dead load, I don't know if you can see, but you know, we got the unit breakup. Our normal X's are here, right? Because I'm just trying to figure out, you know, I'm counting the weight of the unit because, like we talked about earlier, the curtain walls, mat clips, the gravity load, we're all hanging on from the top. So I'm just trying to figure out the weight of that unit. When you're figuring out the wind load, you can't blindly do that, okay? Because this ground floor unit's getting wind load at the sill runner and it's getting wind load at the mat clip, okay? But then this mat clip's taking half the wind load of the upper portion of the lower unit and the lower portion of the unit up above. Okay, so once you get into a tall curtain wall, like in floors 2, 3, 4, 5, and 6 are all the same height, like all the stuff in the middle of the building is all the same load. You just figure it out once and then it's the same shit everywhere. But if you had like a taller ground floor, if this floor is 15'6" and this floor is 14'3", to figure out the wind load of that anchor, you'd have to take 15'6", divide by 2. So you divide that by 2, it's 7'9", and then this 14'3", and divide by 2, That's 7'1.5" plus 7'9". So the height of the tributary area that's being applied to that mat clip is 14'10.5". Okay. And then because all this mullion spacing is luckily all 5 foot, you take that 14'10.5", multiply it by 5 feet, and then that gives you 74.375 square feet. All right. Now to figure out your wind load, you take that 74.375 and you multiply it by the wind load you got from your calcs. So you multiply that times 22.73. So this mat clip is supporting 1,690 pounds of wind load. Does that make sense? Yes, no?
Yes, it does.
Okay. Let me see if I got that right over here. So here's kind of the math of it. So the dead load on the mat clip, like Caesar and I were talking about, then it was 15'6". It was a taller square footage, but for this upper floor, this unit's 14'3". So you just go 5 foot by 14'3", 71.25 times 10 is 712 pounds there. To figure out this wind load, you would take the 15'6", 15'6", divide by 2, because you're only worried about the lower portion of the wind load, get you 17'9" times 5, that equals 38.75 square feet is the tributary area of the wind load at this chicken head, at this sill runner. And you multiply that by 22.73. So we just said that this mat clip's getting 1,690 pounds of wind load. This sill runner is getting 880.79 pounds of wind load right there. So that's kind of it. That's all I got for today. But are there any questions? Does this make sense? It's a little complicated, but like literally once you do it like 2, 3, 4 times and you just kind of get used to it, you're just trying to figure out the square footage area surrounding that anchor or that connection. And then if it's dead load, you multiply it by the weight of the thing. So 10 pounds a unit. If it's wind load, you just got to go look at your calcs, figure out your design pressure, multiply the square footage by that. And then you can figure out, you don't have to wait for jump start. You can be the smartest guy in the room and you can go, get things done in the design meeting pretty quick. So I found it to be helpful. Are there any other questions there? Nope. A lively bunch today.
Thanks, Brian.
Yeah, this was super
Thanks,
helpful.
Brian.
Thank you,
Thank you,
Brian.
Brian.
Okay.
Yeah, it was
All right,
good.
right on.
Good job, Brian.